The next question we'll look at is letter A, part 9, which is big F prime of 4, because now things aren't just area. Everything in parts 1 through 8 was just an area problem on repeat. But now that we have this big F prime, we have a little bit of legwork to do to make sure that we understand what big F prime means and how we can ensure that we understand what to do with this 4 in the context of the graph, which is little f. So big F prime and the graph don't necessarily have to do directly with each other, and we want to make sure we understand that connection. To do that, let's bring back the second fundamental theorem of calculus. If you're not sure what I mean, perhaps it'll make sense once we explain why the prime really is something that we've seen before and need to recognize as important. I'm just copying out onto my scratch paper here the big F function that they gave us from the original question. So remember, big F of x is the integral from 0 to x. Prime in this question means we want to take the derivative of big F. So the derivative of big F is requested of us, so we'll take the derivative of that function. That also means we're going to take the derivative of whatever's on the other side as well. And I'm writing this symbolically not because we normally do this when we take derivatives, but to illustrate that we know something really important when we take the derivative of an integral. Now, of course, we can be liberal with our notation here. I used the ddx notation just because that was how we looked at it when we did the second fundamental theorem of calculus in those previous lessons. But if you want to switch to prime notation, that's fine. F prime, the derivative of f, is the derivative of the integral. And we've seen this before. A derivative of an integral cancels each other out. That's the whole beauty of the fundamental theorem. So knowing that, we kind of have to go through those same steps. Remember those steps for converting something with a dummy variable and taking the derivative of an integral? Technically, what we need to do is write out the function, because the derivative and the integral are going to cancel. We plug in the new variable into where the dummy variable was, and then we do the chain rule. We multiply by the derivative of whatever we just plugged in, which is just 1, and that's kind of trivial. Now, of course, if I clean this up a little bit, I have that big F prime of x is equal to little f of x times 1 is just little f of x. Now, this is actually really important. So important, I'm actually going to highlight it because that is so crucial. And I'm even going to copy it onto my paper because I feel like that's so important. Big F prime of x is actually equal to little f of x. And if you're not sure why that's important, I think you'll immediately grasp the crucial nature of this fact once we have to do part 9 here, which is big F prime of 4. Because think about what that would look like as a substitution. Big F prime of 4, according to the fact we just established, is really little f of 4. If we use this fact and simply substitute the 4's where the x's are, then big F prime of 4 is really little f of 4. And if I think about this, little f is just a graph. Little f is just a picture. So little f of 4 must simply be the function value at 4. If I go to my graph and go to the x-coordinate 4, the function value at 4 is simply the y-coordinate of the point on the graph at x-coordinate 4. It looks like that y-coordinate is 0, so that means the answer they're looking for must be 0. So realistically, I didn't actually have to do a whole lot once I knew that the fact was true, that big F prime is really just little f. And little f is just function values. So if you want to make that note to yourself, this big F function, or big F prime function as it were, is really just asking you for function values. Or, if you prefer to state it this way, y-coordinates. So if you'd rather think of this whole idea as big F prime of 4 really just means y-coordinate of 4, that might make your life a little bit easier. Take a look at the next one and just see if you can kind of follow this logic here. Big F prime of 2, by substitution into our key fact here, is little f of 2. Now, once you know where the key fact came from, and this is the derivation here over here on my scratch work, you don't have to keep doing it every time. You don't have to keep finding big F of x and keep taking the derivative and canceling the integral and plugging in the dummy variable. You don't have to keep doing that. Once that fact is established, you can just roll with it. Once we know that big F prime is the same as little f, just skip the whole derivation step and go straight to the function, because now this means that I'm finding little f of 2, I'm finding the function value of 2, I'm looking at the picture and finding the y coordinate at that x value. So it looks like if I go to the x coordinate 2, the y coordinate at that point is 2, thus the function value is 2. So function value, super straightforward, because that just means look at the graph and say the y coordinate. See if you can try part 11 and part 12 using the same idea. You're just looking at the graph and writing the y-coordinate, and again looking at the graph and writing the y-coordinate. The reason for it is because of the fundamental theorem, but in execution you don't have to do any calculus here. You're just finding y-coordinates. Between now and the time you start the next video, try part 11 and part 12. Make sure that idea makes sense, because in the next section, part 13, we're going to do big F double prime, and I want to make sure that that evolution of big F is becoming clear each step of the way.